Hello students, good morning and assalamu alaikum to all. Welcome to this online lecture series. I am Dr. M. Anwar Sadiq, Assistant Professor, Department of Chemistry, Jamal Muhammad College, Tiruchirappalli, Tamil Nadu. Today, we will discuss some basic informations about solute, solvent, solution, salt, salt solution, preparation and handling of few salt solutions. Before to enter this topic, today's positive message for us is education. Education is an instrument for man making. Education is an instrument for man making. The power of education is immeasurable. Education is the most empowering force in the world. It creates knowledge, builds confidence and character, develops attitude, and breaks down all the barriers and open the door for opportunity. Dear students, it is their key to open the door to a better life. Now, I move to today's presentation. Now I share my screen. I hope screen is visible to all of you. Now I present today's topic, preparation of salt solution, part 1. Objective of this presentation is to understand the meaning of various terminologies. What do you mean by terminologies? Salt, solvent, solution, these are all different terms. What is the meaning of these terms? That is known as terminologies. The second objective is to know the significance of salt solutions. Third objective of this presentation is to learn about the preparation of salt solutions. Fourth one is to analyze the nature of different salts. Fifth one is to study the methods of handling and storage of some chemicals. Right? What do you mean by solution? Solution is a homogeneous mixture. Simply, solution is a homogeneous mixture. It contains at least two components. Solution is composed of two or more substances. In such a mixture, a solute is a substance dissolved in another substance known as solvent. Here, at least two components are needed. One is a solvent, another one is a solute. Right? Solution is a homogeneous mixture of at least two components. What do you mean by solvent? Solvent is a substance that dissolves a solute. That is, it is able to dissolve some other compound. That compound is known as solute. The another role of solvent is solvent dilute the other substances. Therefore, solvent is a major component in a solution. I already told that solution is nothing but it is a homogeneous mixture. It contains at least two components. One is a solvent and another one is a solute. Here, solvent is a major component, solute is a minor component, right? A solvent is usually a liquid. People may think that solvent is usually a liquid, right? Please wait. தம்பி யாரும் ஸ்கிரீனை வந்து நீ ஷேர் பண்ணக்கூடாது. இப்போ தம்பி யாரோ ஒருத்தர் ஸ்கிரீனை வந்து அவர் ஷேர் பண்றாரு, அதனால என்னுடைய ஸ்கிரீன் போயிடுச்சு. நான் ப்ரெசென்ட் பண்ணி முடிக்கிற வரைக்கும் யாரும் ஸ்கிரீன் என்ன செய்யக்கூடாது அப்படின்னா ஷேர் பண்ணக்கூடாது. நான் திரும்ப ஷேர் பண்றேன். Okay. What do you mean by solvent? What do you mean by solvent? Solvent is a substance that dissolves a solute. Right. A solvent is usually a liquid, but can also be a solid or a gas or a supercritical fluid. Water is an example for a grainer solvent. Right. What do you mean by solute? Solute is a substance that can be dissolved by a solvent to create a solution. Solute, anything may be called as a solute. The condition is it can be dissolved by a solvent, right? It is a minor component in a solution. Common salt, that is sodium chloride, is an example for a solute. In a sodium chloride solution, salt, that is NaCl, is a solute. Water, H2O, is the solvent, right? What do you mean by salt? Salt is a compound composed of two ions, right? One is a positively charged ion and then another one is a negatively charged ion. Common salt, sodium chloride, that is NaCl, is an example for a salt. How will you prepare a salt? Salt is prepared by the reaction of an acid and a base. For example, strong hydrochloric acid reacts with a strong base sodium hydroxide to form sodium chloride. Here, charge separation may take place. Separation of positively charged like sodium ion. Similarly, separation of negatively charged ion like Cl minus chlorine ion. Right? The attraction between the two ions forms a stable, strong ionic bond. Therefore, salts are usually ionic in nature. Salts are usually hard and brittle, crystalline in shape. Right? The important criteria is freely soluble in water. According to Arrhenius, salts are freely soluble in water. That means dissociation of ions may take place. Here, NaCl, KCl are all examples for strong electrolytes. What do you mean by strong electrolytes? Here, 100% of charge separation may take place. You know, potassium chloride is an example for an isoelectronic. Potassium chloride is an example for an isoelectronic species. Why? Because here the atomic number of potassium is 19. Similarly, the atomic number of chlorine is 17. In a water solution or a solvent, the atomic number of K plus ion is 18. Similarly, the atomic number of Cl minus is 18. K plus as well as Cl minus, both ions to reach the same electronic configuration. Therefore, this is known as isoelectronic in nature. Here, 100% of charge separation is possible. That is formation of 100 K plus ions. Similarly, formation of 100 Cl minus ions. You know, in periodic table, lithium, sodium, potassium, rubidium, cesium, and francium all are collectively known as alkali metals or first A group elements. The basic nature of these elements are more electropositive in nature. Why? Because in all these elements, only one electron is available in the respective compartment. Therefore, these elements easily to lose their electrons to form a stable noble case configuration. Similarly, you see fluorine, bromine, iodine, these are all collectively called as halogen family. These elements are more electronegative in nature. Why? Because only one electron is required to reach the acted stable configuration. Therefore, alkali metals and then these halogens to make a effective ionic bond. Therefore, salts are ionic in nature. Similarly, salts are very good conductors. Why? Because here ions are there, therefore to conduct electricity. Fourth one, what do you mean by salt solution? Salt solution is a mixture of salt and water. Here salt solution is homogeneous in nature, right? NaCl solution is an example for a salt solution. Here salt is a solute, water is the solvent, right? Dear friends, we have to prepare a salt solution. Some general instructions we have to follow. What are the general instructions? It is highly recommended that the following precautions must be duly followed while preparing the reagents in the laboratory. The first one is always wear a lab coat and safety glasses. The second one is wear disposable gloves while dealing with highly poisonous and irritant chemicals. Third one is use clean and dry glass apparatus while preparing the reagents because to minimize errors. Fourth one is maintain a safe distance while using the chemicals. Fifth one, dispose of any waste paper or any kind of solid waste properly. Sixth one, never touch or taste or smell any chemical, whatever it may be. Seventh one, make sure no flammable solvents are in the surrounding area when lighting a matchstick or a burner. Eighth one, hold containers away from the body when transferring a chemical or solution from one container to another container. Ninth one, concentrated acid. Add concentrated acid to water slowly. Never add water to a concentrated acid. Dear friends, it is very, very important. Never add water to concentrated acid. Store the reagents after proper labeling, right? Now, we see some of the formulas, formula and calculation. Here, one important formula is N1V1 equal to N2V2. This formula is we frequently used in volumetric analysis, right? Here, four terms are there. Normality of a compound 1, normality of a compound 2, volume of a compound 1, and then volume of a compound 2. Here, any three, we know from these three no values, we have to extract the fourth one, right? Therefore, N1V1 is equal to N2V2. From this, we have to extract any meaning, right? The second formula is normality. What do you mean by normality? What is the use of normality? Dear friends, here we have to prepare a solution. The solution concentration is expressed in many ways. What are the many ways to express the concentration of solution? Like normality, molality, molarity, parts per million, moles. These are all various units available to express the concentration of a solution. Here we have to use normality. What do you mean by normality? Normality is defined as the number of gram equivalents of the solute dissolved per liter of the solution. What do you mean by equivalent weight? Equivalent weight is also known as gram equivalent. Simply, equivalent weight is the mass of one equivalent. Equivalent weight is the mass of one equivalent, right? The next one is preparation of ammonium carbonate solution. Now we move to particular case, preparation of ammonium carbonate solution. What is the formula of ammonium carbonate? NH4 twice CO3. Why is it called as a salt? Why is it called as a salt? Because in a solution, ammonium carbonate present in two forms. One is a cation, another one is a anion. Here ammonium ion is a cation, that is positively charged particle. Carbonate, CO3, 2 minus, is an anion, that is negatively charged particle. Therefore, ammonium carbonate is called as a salt, right? Second one is how to make a ammonium carbonate solution. What are the requirements? Requirements in terms of chemicals. We need pure ammonium carbonate substance and then distilled water. Apparatus. Volumetric standard flask is required. Stirrer is required. Similarly, container, that is beaker, is required to make a ammonium carbonate solution. Right? Now we have to prepare 4 normal ammonium carbonate solution or 2 molar ammonium carbonate solution. Here 4 normal ammonium carbonate solution is equal to 2 molar ammonium carbonate solution. Why? The molecular mass of ammonium carbonate is 96 gram per mole, but the equivalent weight of ammonium carbonate is 48. 96 divided by 2. Therefore, 4 normal ammonium carbonate solution is equal to 2 molar ammonium carbonate solution, right? Here the formula is N is equal to, N is represented by normality. N is equal to amount or weight in gram divided by equivalent weight into 1000 divided by volume. Here volume means we have to select the standard flask. Which standard flask? We have to select it, right? Here we have to make a 100 ml standard flask or a 250 ml standard flask or 500 standard flask or 1000 ml standard flask. Now we have to take 1 liter standard flask. Therefore, 1000 divided by 1000. What is the amount of ammonium carbonate? I don't know. Therefore, put in the place of amount X. X divided by 48. 48 is the equivalent weight of ammonium carbonate. Right? We have to prepare 4 normal ammonium carbonate solution. Therefore, in the place of normality, we put 4 normal. From this equation, we have to calculate the amount, right? X is the amount of ammonium carbonate. From this simple arithmetic equation, we have to extract the amount. Here X is equal to 190 gram. 192 gram is the correct amount of ammonium carbonate to make a solution. The concentration of the solution is 4 normal or 2 molar, right? Procedure for the preparation of ammonium carbonate solution is weigh accurately 192 gram of the pure ammonium carbonate solid and transfer to 1 liter standard flask or volumetric flask, right? Dissolve the salt using distilled water, right? Here ammonium carbonate is readily soluble in distilled water. No problem. Here we have to add distilled water until to reach the mark. You are all see the standard flask, therefore no doubt about it, the making of a solution. Final one, label the container. That is, label the container means in the container you write the name of the solution, ammonium carbonate, right, and date of preparation. Now this is the general instruction: storage and handling of ammonium carbonate solution, right? Ammonium carbonate solution should be stored in a tightly closed container. Store in a cool, dry, well-ventilated area away from incomplete substances. Do not store in metal containers. Don't expose to air because hygroscopic in nature. Some water molecules may be absorbed by ammonium carbonate or decompose or disintegration may take place, right? Avoid contact with eyes, skin and clothing. Wash thoroughly after handling. Remove contaminated clothing and wash before reuse. Precautions. Ammonium carbonate as an alkaline in nature, right, can corrode and burn you. Irritation may take place. If ingested, it can be toxic and it can severely damage our eyes. Therefore, we have to handle ammonium carbonate carefully, right? The second one is preparation of ferric chloride. First one is ammonium carbonate. Second one is ferric chloride solution. The formula of ferric chloride is FeCl3. Some amount of water is persist in ferric chloride solution. Therefore, the actual formula of ferric chloride is FeCl3 6H2O. Here, hexahydrate is there, 6H2O, hexahydrate. Here the oxidation state of iron is +3. +3 is the oxidation state of iron. Here we have to prepare a ferric chloride solution in a particular strength. Some of the apparatus are required. What are the apparatus we needed for this preparation? Number one is standard flask. Same standard flask, stirrer, container or beaker is required. What are the chemicals required to make a ferric chloride solution? Ferric chloride 6H2O, it is a parent compound in pure form. Distilled water. The third one is concentrated hydrochloric acid. In case one, in the preparation of ammonium carbonate solution, we have to need only two solutions, only two chemicals. The number one is ammonium carbonate, the number two is distilled water alone. Here, third one is required. Why? Because we have to prepare a homogeneous solution. Some amount of concentrated hydrochloric acid is required to make a or to attain a homogeneity. Therefore, we have to add a few drops of hydrochloric acid in the preparation, right? Here we have to prepare 0.5 normal strength of ferric chloride solution. Molecular mass of ferric chloride hexahydrate is 270 grams. Similarly, the equivalent weight is also same. Normality we know. Here put the content in proper place, we get the amount. Here X is equal to 135 gram. Now weigh accurately 135 gram of hydrated ferric chloride salt. Here step 2 is very important. The 135 gram of hydrated ferric chloride salt is distilled or dissolved in distilled water containing 20 ml of concentrated hydrochloric acid, right? Add more distilled water to this and make up the solution up to the mark in a standard flask. Label the container with the name, date and a batch number. The next one is storage and handling of ferric chloride solution. Iron 3 chloride, that is ferric chloride, is highly toxic. highly corrosive and acidic in nature. Therefore, care to handle it. The anhydrous material is a powerful dehydrating agent. Keep container tightly closed, store protected from moisture. Don't get on skin or in eyes. Do not ingest or inhale. Use with adequate ventilation. Always wear safety glasses. Don't allow the acid to any other parts of our body, right? The final one is preparation of ferrous sulfate solution. In example 2, we have to prepare ferric chloride solution. In example 2, the oxidation state of iron is 3. Here, in ferrous sulfate, the oxidation state of iron is +2 FeSO4. Fe +2 SO4 2 minus. Here also, ferrous sulfate contains some water molecule. Ferrous sulfate heptahydrate FeSO4 7H2O. Chemicals requirement for the preparation of ferrous sulfate solution is ferrous sulfate, heptahydrate, distilled water, and concentrated hydrochloric acid. Why here we have to use it concentrated hydrochloric acid? Because to make the homogeneous, right? Same apparatus is required. We have to prepare 0.5 normal ferrous sulfate solution. The molecular mass of ferrous sulfate 7H2O is 278. Similarly, the equivalent weight of ferrous sulfate heptahydrate is 278. Same molecular formula, same equivalent weight, right? Molecular mass as well as equivalent weight is same. We have to use the same formula. The weight of ferrous sulfate heptahydrate is 139 gram. Here we have to prepare 1 liter solution, ferrous sulfate solution. Weigh accurately 139 gram of hydrated ferrous sulfate salt. Transfer this salt to a standard flask, 1 liter standard flask, and add 7 ml of concentrated sulfuric acid. Now add a little water to dissolve this salt, right? Slowly add the distilled water to the standard flask, dissolve completely the ferrous sulfate hydrated salt, and then add more distilled water to this and make up the solution up to the mark in a standard flask. Label the container with the content, date, and batch number. Storage and handling of ferrous sulfate solution. Avoid contact with eyes, skin, and clothing. Avoid breathing dust. Minimize the dust generation and accumulation. Don't store in direct sunlight. Store in a cool, dry area away from incompatible substances, right? Use with adequate ventilation, right? The next one is